Hi class, how's everyone doing? Can everyone hear me okay? Perfect, so let's get started. So today we're going to talk about the aggregate expenditures model, and this is chapter 6 in the textbook. We talked about the aggregate demand and aggregate supply model. Now, in that model, we had aggregate demand and aggregate supply interacting and determining the output, and then as a consequence, income and employment, and also prices, the price level. Now, this week we're going to look at the aggregate expenditures model, which is sometimes also known as the Keynesian cross. So aggregate demand is the total amount of aggregate expenditures at various prices, and that's what we looked at in the last lecture. If you remember, on the vertical axis, we had the price level, okay? And so we had aggregate demand at different price levels. Well, here with the aggregate expenditures model, we're holding prices fixed. We're thinking we're in the very short run. And so here we're going to be looking at how GDP could be determined with prices held constant. So we'll get a little bit more into that later. But just to, the bottom line is the aggregate expenditure model focuses on the very, very short run relationship between total spending and real GDP, but holding the price level constant. And then we'll see at the end of the lecture, we can derive the aggregate demand curve using this model. So the aggregate expenditures model is also referred to as the Keynesian cross. And John Maynard Keynes is the one who came up with this model. And just giving you some context about the model, behind the model, or some background information. During the Great Depression, it caused many economists to question the validity of the neoclassical economic theory. In that theory, it basically said that prices and wages would adjust very quickly, and so that if there's a surplus of labor in the labor market, for example, the wage would fall quickly and unemployment would be only, short-lived. But of course, in the Great Depression, that wasn't the case. So he came up with a new model that was required to explain such a pervasive economic downturn and to suggest that government policies might ease some of the economic hardship. So in a nutshell, the Great Depression sort of put into question the neoclassical way of thinking. In the Great Depression, the unemployment rate was around 25%, and even 10 years later, it was still roughly 17%. So clearly, wages and prices and that sort of thing weren't adjusting quickly. So Keynes proposed a low aggregate demand. Well, essentially, he proposed that you sort of get into a rut. You have something happen like the stock market crash in the Great Depression that causes aggregate demand to be very low, and that's responsible for low income. There's less being produced and high unemployment. So basically, you can kind of get stuck into this situation in the short run where you are you have inadequate spending. And so he criticized the idea that the aggregate supply curve can, just adjust on its own and get us back to full employment. So in 1936, Keynes proposed that an economy's total income was, in the short run, mostly determined by the desire to spend by households, firms, and the government. So the more people want to spend, the more goods and services firms can sell. The more firms can sell, the more output they will choose to produce, and the more workers they will choose to hire. So the problem during recessions or depressions, according to Keynes, was inadequate spending. So you have this shock, it puts the economy into a situation where spending isn't very large, and firms aren't going to produce more than what people want to buy. So you get stuck into this situation where you're not, the overall aggregate demand is very low, meaning that the production's very low and you're overall below your potential GDP. So the Keynesian cross model was an attempt to model this insight. So we did talk about this a little bit earlier. So if you think of the Keynesian aggregate supply curve, it would look something like this. If we're below our potential GDP, then if we increase aggregate demand, like you can think of aggregate demand curve shifting here, that would have the effect of increasing real GDP, and there wouldn't be much of an impact on prices. But in the neoclassical idea, they didn't really think of any short run. They just said basically markets would adjust very quickly. And so if there's any increases in aggregate demand, it would just immediately cause the prices to increase. So the Keynesian aggregate supply curve implies that anything that leads to a fall in a nation's aggregate demand will cause little or no fall in prices in the economy but a significant decline in real GDP. On the other hand, the neoclassical aggregate supply curve was just the potential GDP, the long run. So it's vertical, so it implies that no matter what happens to aggregate demand, the nation's output and employment will always remain at the full employment level. I mean, there might be a little bit of time lag. There'll be unemployment for a little bit, but it won't last very long. So we might as well just look at the long run. And that's sort of what the idea was. So the Keynesian cross model can be viewed as showing what causes the aggregate demand curve to shift. So in the short run, when the price level is fixed, so just assume in the economy that there's not enough time for firms to adjust their prices. Then if you have a shift in the aggregate demand curve, that's going to lead purely into changes in output, right? If we have our aggregate demand curve here and it shifts to the right, then the new intersection point would result in higher real GDP. You can just think of just think about it. If all of a sudden people have more incomes or whatever that would make them want to buy more stuff, so somehow you stimulate aggregate demand. Well, if prices aren't changing, then people will just want to buy more. But if prices go up, that would cause people to buy a little bit less. So the Keynesian cross model, if you think about the space that we looked in last time where we have the price level and real GDP, the Keynesian cross model is developed for at a fixed price level. So we're looking at, if aggregate demand increases, what would happen to real GDP? And since prices are fixed, it would directly impact real GDP. So the components of the aggregate expenditures model are the same as aggregate demand. So we categorize things the same way. We have consumption, investment, government spending on goods and services, and net exports. Okay, so the aggregate expenditures in economy will equal C plus I plus G plus net exports. Let's look at each of these in turn. So we're going to be developing a model here. So the consumption function. So the first thing we're going to do is model the consumption function with a very simple linear equation. We're going to say that consumption is equal to some intercept. So this is the amount of consumption that would occur if income was zero. Okay, and so we call this autonomous spending. This is the portion of total spending that is independent of the level of income. And then the other component here is dependent on income. And so this is called the marginal propensity to consume. So if we look at some data here, so we have some hypothetical data. So here we're saying that we have some different levels of income or production for an economy. So if this economy doesn't do anything in a year, for example, so they don't do any production, so there's no income, well, they still need to obviously eat somehow. And so we're saying here that their consumption would be 50. And then if we think about savings, well, they would have to borrow somehow to be able to consume if they didn't produce anything and they don't have any income. And so we just vary the income level here. And so given this consumption function, we're told that if national income is 100, if we plug 100 in here, we'll get 75 plus 50. And so our consumption would be 125. Okay, again, we only produced this amount, so that's our income. We consumed more than that, so again, our savings would be negative. So this savings would be like borrowing. Or if there was if you think of maybe some inventories of food or something like that, those would be depleted. Okay, if the income is 200, we plug 200 in, and at this point, we would get that consumption is equal to 200, which is exactly what the economy produced. So there would be zero savings. And then further, if we plug in points, we see that consumption would increase and then savings would increase. Okay, so this is the consumption function. So the first part is consumption. We're going to model it with a simple linear equation where we have an intercept term that's autonomous spending, and then induced spending is the second part, where this is telling us that we'll consume 75% of whatever their income is. Okay, so that's the autonomous part. And here, obviously, this would be the slope of the consumption function, because this would tell us this is basically the ratio of the change in consumption with respect to a change in income. And so it's 75 divided by 100. This is linear, so it's the same throughout. So the slope is 0.75. So the consumption function tells us how much the economy consumes out of income. And the slope of this thing is called the marginal propensity to consume out of income, right? Because it's telling us, how if this increases by 10, then our consumption will increase by 7.5. Okay, what does this look like on a graph? Well, if we were to graph it, it would look like this. We have our intercept term at 50. Slope is 0.75. So if we did our delta y over delta x, or rise over run, we would see that the slope is 0.75. So here the rise is 150, or the change in consumption divided by the change in income. Here is 200, so 150 divided by 200 is equal to 0.75. Now we could draw the savings function. Now savings is of course just equal to how much you don't spend, right? So if you think of your income is equal to how much you consume plus how much you spend, and if we just were to solve for S, we would get this expression here. Okay, so savings would be equal to negative 50 plus 0.25y. We'll mostly be looking at this consumption function. We won't spend too much time looking at the saving. Obviously here we have the slope, which is 0.25. So the marginal propensity to consume plus the marginal propensity to spend will always equal to 1. Okay, so the next component of our model is investment. So remember, we have C plus I plus G plus X minus M. Here, we're looking at the I part, investment spending. And we're going to keep things simple. We're going to say that investment is just a constant number. Now, investment spending is far more volatile than consumption spending. So if you think of the economy, for example, with this COVID-19 situation, businesses are going to likely reduce their investment spending immediately. They're not going to, they're going to be worried. So they're not going to put forth any investment spending. So investment spending can be easily put off by firms. But if you think of households, individuals, consumption spending doesn't change as much. But businesses can all at once quickly reduce how much they invest. So it tends to be more volatile, mainly because it can be postponed. So it's kind of less dependent on income compared to consumption. So it's not a perfect assumption because, an economy that's very large, with a very large income compared to one that's small, is obviously going to have more investment overall. It can change a lot over time. So we're just going to make a simplifying assumption and assume that investment is constant at 75. So in our ongoing example, we'll set it equal to 75. Okay. Now, if we were just to consider consumption and investment as part of our model, we're going to add government and the foreign sector later. But for now, just to see how things work, let's assume that this economy doesn't have a government or trade. So it's, it's a closed economy and there's no government. So there's just two spending sectors, consumption and investment. So the C plus I. So then now we're going to talk about what would be an equilibrium in this model. The equilibrium will be where aggregate expenditures equals income or production. So the income at which the value of production and aggregate expenditures are equal. So saying that if Y is equal to AE, we're at equilibrium. So a way to think about why we think that's an equilibrium is to think about when this doesn't hold. So if what we produce, and so that's our income, is less than what people want to buy, in this case, we would end up with a situation where we'd have to deplete previous year's inventories. If this is the case, then firms would actually want to produce more. Okay, so it's not really stable. If we produce too much, right? So if production is greater than aggregate expenditures, then we have inventories building up. And so then production would fall. So we would have a tendency to go towards where we have Y equal AE, and this is where the production or income in the economy is equal to aggregate expenditures. If you just think about it, firms in the economy aren't going to want to produce more than what people want, and they don't want to produce less. They want to produce where it's the same, so there'd be a tendency to go towards this equilibrium. So there's this term called unplanned investment. So this refers to the unintended investment by firms in the form of a buildup or rundown of inventories. So in these cases here, we're either, if we produce less than what people wanted, then we're going to deplete our inventories. And so we're saying that's a negative unplanned investment. If we produce too much than what people want and inventories are building up, that's a positive unplanned investment. So let's look at our ongoing example with the numbers. And again, we're just looking at the C plus I. So we're assuming there's no government or foreign trade. So if you remember before, we had our national income and we're just varying it from 0 to 800, and the changes here are all equal to 100. And so we can use our consumption function to get these values here. Okay, so this would be the consumption at the different levels of income. This would be savings, is just the income minus your consumption. Just like when you get your paycheck, if you have a certain amount of money that you have, if you don't spend it all or consume it all by buying goods or services, then you have some left over and that's your savings. If you spend more than your income, then you must have to borrow. Investment, we're just holding it fixed at some level. And so our total aggregate expenditures at each of the income levels is given in this column. Here we're just simply adding consumption plus investment. So we have our aggregate expenditures here. Now, where would be the equilibrium? Well, the equilibrium will be where aggregate expenditures equals national income. And that would be the point right here. 500 be in millions of dollars. So when the income is 500, aggregate expenditures is equal to 500. And so only at this point will we have that unplanned investment is equal to 0. So in this economy, if the production was 200, the consumption would be 200, savings would be 0. We actually have investment that's positive. So our overall aggregate expenditures is higher than our national income. So then we would have to have a negative unplanned investment. So we can think of our inventories as being depleted. If the income is very high at 800, our consumption would be 650. End up saving some of that. We would save quite a bit. And our investment is 75. So our aggregate expenditures would then be 725, consumption plus investment. But here, the aggregate expenditures exceed or is less than the national income. So firms would end up building up their inventories because they produce too much. And they're not going to want to do that. They're going to want to produce less in the next round, you can think. Maybe you can think of the circular flow as having different rounds. So if this were to happen, the next round, the firms would produce less. So there'd be a tendency to go back down towards the equilibrium point. For here, we have a tendency to go down. So in equilibrium, we're going to have unplanned investment is equal to 0. And now if you look at if you remember, savings is a leakage and investment is an injection. So only at this level here do we have savings and investment being equal to each other. So in equilibrium, the savings and investment have to be equal to each other, okay? If you think about it, we have national income being 500. Our consumption is 425. So that means we're having savings of 75. So in order for us to be able to, in order for aggregate expenditures to be equal to 500, investment also has to be equal to savings. So in equilibrium, the injections will equal the leakages. And this is similar to when we talked about the circular flow. In equilibrium, the injections equal the leakages. So if you think of my analogy with the water going around a hose, then the pressure of the water is constant and it's not changing. Okay, so the aggregate expenditure function. So let's get an actual little equation here, just simple linear equation that characterizes the aggregate expenditures function. So it's very simple. We're going to add consumption and investment. So we know our consumption function is equal to this, 50 plus 0.75y. We know that investment is equal to 75. So we just add them together. We get our aggregate expenditures function. Okay, so the aggregate expenditures function incorporates all of the components. So at this point, we just have consumption and investment. Later, we'll add government and the foreign sector. So now, when we talk about the slope of the aggregate expenditures function, we're going to refer to it as the marginal propensity to expend. We're not going to refer to it as the marginal propensity to consume. When we say the marginal propensity to consume, we're going to think about the consumption function. It just so happens here, because we only have these two sectors, the slope of the consumption function is the same as the slope of the aggregate expenditures function. So in this case only, will the marginal propensity to consume be equal to the marginal propensity to expend? When we add the government sector and imports, that's not going to be true anymore. The slope of the aggregate expenditures function will be different than the slope of the consumption function. Okay, so just keep that in mind. So what's going on graphically? So here's our aggregate expenditures function. Okay. So, and again, this is just basically the consumption function, but shifted up by 75 because of the investment that we added. So now, if we want to find the equilibrium, we need to find where on this line aggregate expenditures is the same as national income? Well, an easy way to do that is just to draw a 45-degree line. 45-degree line just shows points where the vertical and horizontal axis are equal. And so we look for where it intersects the aggregate expenditures function. And so in this case, it's at 500 and 500, which we saw in the table of numbers before. So any income levels below, we're going to be having a shortage because the amount people want is greater than the production. Here we have surplus. So there's a tendency for us to go to the equilibrium point here. So we'll call this the expenditure equilibrium. And the big picture, we're just thinking of an economy, simple economy. Now, prices aren't allowed to change. So all prices are fixed. And we're just thinking of the total amount people want to buy, at those prices, their expenditures. And we're thinking about different levels of production. And we're saying that there's a tendency for the economy to go towards where what people want to buy, their aggregate expenditures, is the same as what's produced, which is equal to income. There's a tendency to go there because if we're not at such a, if aggregate expenditures doesn't equal income, then we're going to either have a surplus or shortage, and that will push us back towards the equilibrium. And so again, in the equilibrium, we will always have that leakages will equal injections. So if we look here, these are our leakages. As income rises, our savings increases, and we have that the injections are fixed at 75 for investment. So when these two are equal, our equilibrium will be. Let's talk about this concept called the multiplier. Okay, so think of the multiplier as a respending effect. So I'll read this quote from Keynes. If the new expenditure is additional and not merely in substitution for other expenditures, so he's talking about an injection. So if we have an injection into the circular flow and it's not met by a corresponding leakage, then the increase of employment does not stop there. So if you think of the circular flow, if you increase the pressure, it just doesn't immediately, stay at that pressure. It's going to have further increases until it steadies off. So the additional wages and other incomes paid out are spent on additional purchases, which in turn lead to further employment. The newly employed who supply the increased purchases of those employed on the new capital works will in their turn spend more, and thus adding to the employment of others and so on. So the idea here is if there's an injection into the economy, so suppose the government borrows money and builds a highway. So this is all, a new injection. So it's not merely a substitute for another expenditure. So if the government took money directly from other people in the economy and used that to build it, so that money would have been spent on something else, but now it's being spent on the bridge, then that's not what we're talking about. We're talking about, the government, say, taking money that wasn't going to be spent, like borrowing it, and then using that to purchase something. So we have an injection into the circular flow. And so suppose the government decides to borrow money and purchase a highway. Well, when you construct the highway, all of that, there's going to be income to the construction workers, the firm, all that's going to become income to people. Now they're going to respend it. That's going to become income to other people. They're going to respend it, and so on. So the initial increase in GDP or income, that initial spending amount, is not the whole story. It will continue because of the respending effect. So suppose the government increases public expenditure by 50 billion, keeping taxation at its existing level. So we have an injection, but the leakage is not going to increase to offset it. The government could increase transfer payments, or the government might wish to invest in public works or social capital, road construction, for example. The initial increase in income is large. It's $50 million. Households spent 75% of their increase in income on consumption. So the initial people, so whoever whoever constructed this road, the workers, whatever's left over goes as profit to the construction firm. All that becomes income. So that 50 million becomes income to people, and then they're going to spend 75% of it. So when they spend that 38 million now, that's going to become income to other people, and they're going to spend it again, and so on. So further stages of income generation will occur, with each successive stage becoming smaller and smaller than the previous one. So the marginal propensity to expend slows down this process. Let's suppose investment increases by 50 million and the marginal propensity to expend is 0.75. So let's think of different months. So the first month we have the investment. This is we're thinking here of $50 million being spent on, say, a new road or highway. All that's going to become income to people, the construction firm, the workers, whatever the factors of production were responsible for making the highway or road. They're going to get income of $50 million. They're going to consume $38 million because of the marginal propensity to consume. So we're saying they would consume 75%. 38 is 75% of 50, and they're going to save the rest. But now they're going to consume this, so it's being spent, and it's going to become income to other people. Spend 75% of it and save the rest. They're going to now this 28 million is going to be spent. Is going to be spent again. 75% of it will be consumed. The rest will be saved, and so on. And in the end, we will end up with an income increase of 200. So it's not just the initial amount. The initial amount is blown up by a multiple, and that multiple is what we call the multiplier. Okay, so here the multiplier is, can anyone type in the chat what they think the multiplier would be here? So we started at 50 and that blew up into 200. So what's the multiplier? Anyone? You can type it in the chat. Exactly, 4. So the multiplier here would be 4. Okay, so that's the idea of the multiplier. The multiplier in this example is 4. Again, it's a respending effect. So more formally, the multiplier is a number that reveals how much income will change in response to a change in autonomous expenditures. And so its effect on income of a change in autonomous expenditure. The formula for the multiplier in general is given by this expression. So it's just the change in income. So in the last example, it was 200. And with respect to a change in autonomous expenditures, in the last example, that was 50. We had 200 divided by 50, and that equaled 4. You can also get the multiplier by just doing 1 over 1 minus the marginal propensity to expend. So in the previous example, the marginal propensity to expend was 0.75. So 1 minus 0.75 is equal to 0.25. 0.25 goes into 1 4 times. So let's look at our ongoing example. So we have our consumption function, we have our investment, we have our aggregate expenditures function. Now in equilibrium, so I'm going to show you how to solve algebraically for the equilibrium. It's very simple. So in equilibrium, we know y is equal to AE. We're just going to replace this with a y and then solve for y. So y then is equal to 125 plus 0.75y. So all we did here was take this and replace AE with y. Then we just isolate y. We get 0.25y equals 125, and then we bring that underneath. So y is equal to 500. And we know that that was the equilibrium. So to solve for it algebraically, we can just do this procedure. Now, let's look at this multiplier effect. So suppose investment increases by 50. What we're going to do is instead of just having 75 here, we're going to add the 50. Okay, so now we have that y is equal to 125 instead of, we're going to have y is equal to 175. So before we had 125, but now we're adding this 50 because investment was 75. Now it's increasing to 125 because we're adding that 50. Instead of having this, we're going to have this. All we did was add 50 here, and then we're just going to resolve it for y. So when we do that, we'll get y is equal to 700. So we had an increase of investment spending by 50, but the new equilibrium now increased from 500 to 700. So it increased by 200. And that's because of the multiplier of 4. Okay, so the $50 increase in investment caused equilibrium to increase by 200. The multiplier is equal to 4. And so if we take 50 and multiply it by 4, we get that 200. So our initial equilibrium was 500. We add this 200 and we get 700. So clearly the higher the marginal propensity to expend, the larger the multiplier will be. So if the marginal propensity to expend was 0.9 instead of 0.75, then we would have 1 divided by 1 minus 0.9, which equals 0.1. 0.1 goes into 1 10 times. So the multiplier would be 10. And so if that's the case, then the increase would be much larger. We would have 50 times 10, which would be 500, and this would end up increasing to 1,000. Okay, so the higher the marginal propensity to expend leads to a larger multiplier, and decreases in expenditures reduce incomes. So I mean, just think about it. If what slows down the multiplier process is the marginal propensity to expend. So the higher it is, the less it's going to slow it down, because people in every round are going to be spending more. But if it's very low, then they're going to be spending less. So the leakages will slow down the multiplier. So far the only leakage we have is savings. Okay, so later on we'll have taxes and imports, and they will also slow down the multiplier process. So let's see what we're talking about here on a graph. So we have our 45-degree line, have our initial aggregate expenditures function, 125 plus 0.75y. So here the investment was 75 and the slope, or the intercept of the consumption function, was 50. Now we're saying that investment is going to increase by 50. So now this is going to increase the intercept by 50. So we've shifted the aggregate expenditures function up. So the vertical distance here is the 50, right? We're initially at this equilibrium. Now the new equilibrium is here. So we went from 500 to 700. So the 50 increase in autonomous spending, which was investment, resulted in an increase in national income of 200. So just take a break for a second, see if there's any questions. You can type it in the chat if there's any questions. You guys are quiet this morning. No questions? Okay, I'll continue then. So we're going to add government. So now our model is, for aggregate expenditures, is going to include consumption, investment, and government spending. So we're going to treat government as autonomous like investment, just to keep things simple, okay? And now taxes are going to represent with a simple linear function, and they can be autonomous or induced. So we're going to have a simple linear function here. So taxes are equal to some lump sum amount that everyone has to pay regardless of their income, plus 20% of their income. So this isn't very realistic, but I mean, we're just illustrating the model for now. Even if we added a more complicated tax function, just the idea and this model is a good framework to think about the economy, and it's not adding a complex tax function isn't really going to change our understanding all that much. So we're just going to say that that taxes are 20% of your income. So this would be like a flat tax. And then if you don't make any income, you have to pay 60. Okay. So this is the autonomous part. This is the induced part. And so this here would be the marginal tax rate, okay? And it's always 0.2. So let's continue with our ongoing example now, but with this added sector in here. So here's our national income. Now we have to pay taxes now. So if national income is 0, we know that taxes will just be 60. This will be 0, we'll have 60. And so our disposable income then will be negative 60 because we have to pay the tax. Now, if we were to look at higher levels like 500, our tax would be 160 because we're going to plug 500 in here, multiply that by 0.2, and then add 60. And if we do that, we will get 160. So if the economy's overall income is 500 and all the households have to give this amount to the government, then their disposable income would be 340. So we're adding this new term here called disposable income, which is just your income after taxes. So on your paycheck from work, it's the net amount that you get after you pay tax. Okay, and then we're going to consume out of this. So consumption here then would be 305. Let me just fill in these here. So that would be 305. And so if we have a disposable income of 340 and we consume 305, then we're saving 35. So now we have our column for investment that we had before, and then now we're adding in government spending. We're just going to assume government spending is constant at 160. So now when we add up our aggregate expenditures, we're taking our C plus I plus G, and then we get this column. So now what is the equilibrium in this economy? Anyone want to take a guess and type it in the chat function? Yes, that's right. It'll be 600. Okay, so that will be the new equilibrium. And now let's remember our leakages and injections. So in order for us to be in equilibrium, the sum of the leakages have to equal the sum of the injections. And so clearly here, our leakages are taxes, which is 180, and our savings is 55. So we add those together, we'll get 235. If we add our injections, which is investment and government spending, we get 235. And so we'll be in equilibrium. Any of the other levels, we will not have that this is true. If we're at a very low level of income, for example, we're not going to be paying much tax, and we're not going to be saving all that much So we're going to have very little leakages, but our injections here, which is investment and government spending, are constant, and they're going to be much higher. And so here we end up having that the aggregate expenditures is much larger than income. We would have a tendency to go down towards the equilibrium. So now let's continue this algebraic example here. So now we have that the aggregate expenditures function is C plus I plus G. Okay, so we're going to say that the consumption function is 50 plus 0.75, and we're consuming out of our disposable income. Okay, so this isn't big Y anymore. This is disposable income. And then we'll talk about that in a sec. And then we're adding our investment and government spending. So we need to know what disposable income is. We want to get back that big Y here. So disposable income is equal to national income minus tax. So in other words, disposable income is equal to the Y that we want minus taxes. So what we can do is substitute in the tax function, T, which is 60 plus 0.2Y. Okay, and then we just simplify, and we get that disposable income is equal to negative 60 plus 0.8Y. So we're going to plug that back into here, and we'll get our aggregate expenditures function as a function of the big Y that we want. So we're just taking this, plugging it in here, and then we're just, expanding this out. So 50 plus 0.75 times negative 60 plus 0.75 times 0.8Y plus 35, we get this. When we simplify, we get that the aggregate expenditures function is 240 plus 0.6Y. Notice now that the slope isn't the same as the marginal propensity to consume anymore. So the slope and the intercept of the aggregate expenditure function has changed. Before we added the government, we had 125 plus 0.75Y. Now after adding government, our aggregate expenditures function is equal to this. So now let's add the foreign sector. So we have another leakage, which is imports, and an injection, which is exports. So we're going to say that imports are going to be represented by a simple linear function, just like the other cases. We're going to say that people, regardless of income, if the income is 0, they'll import 40 worth of goods. So maybe we could think of the winter time. People, regardless of income, might purchase some vegetables and things like that can't be grown in the winter. But as income goes up, for any level of income, 10% of it will be dedicated towards imports. Okay, so this 0.1 here, this term in front of the income is called the marginal propensity to import, and it's essentially just the change in imports with respect to change in income. Okay, so here we're saying that if income changes by 1, imports will increase by 10% of that. So 10% is the marginal propensity to import. So again, let's continue with our numerical example. So now we're going to add in column here, exports, and we're going to keep things simple and just say exports are equal to 100. And so that makes a lot of sense, because it makes a lot of sense to not have it related to income, because exports really are related to another country's income. So other countries' incomes, if they're higher, they might import more, which means more exports for us. So we're just going to hold that constant, and it makes sense that the amount that people want to buy from us in other countries doesn't depend on our income. It depends on their income. So we're going to fix exports at 100. Imports are obtained just from plugging in the different levels of income into here. So for example, at 300, we're going to have 300 times 0.1. So we're going to have 30 plus 40, and we end up with 70 for imports. Okay. And so, I just noticed that there's some questions. The 0.8. So let me just go back to the last slide and try and answer your question. This 0.8. Okay, so let's see where this came from. So what we're going to do is back here. So we know that disposable income is equal to Y minus T. We plug in the tax function, then we work this out, and then we get Y. There's a typo here. Disposable income is equal to Y minus T. So in front of all here, there's a YD, right? So here we have Y minus 60 minus 0.2Y. So we want to isolate Y here. We have one Y and we owe two Y's. So how many y's do we have? We have 0.8y, okay? And then the negative 60 is here. So we just essentially just factored out here, okay? Does that make sense? So back to the foreign sector. So now we've added our exports, our imports, and our net exports is going to be exports minus import. So now we have the full model. So aggregate expenditures then is equal to C plus I plus G plus net exports. So when we add all those up, so C plus I plus G plus X minus M, or we can just, subtract, add this instead of taking X minus M, the same thing. So here is our aggregate expenditures. And so the new equilibrium then would be at 600. And if we look at our leakages and injections, we have our leakages of taxes, savings, and imports. We add them together, we get 335. Our injections are investment, government spending, and exports. We add them up, we get 335. So let's solve for the full model. So to solve for the full model now, we're going to do C, which is this, plus I, plus G, plus net exports, okay? And net exports is 60 minus 0.1y. Let's just go back and see where that comes from. So we know that imports are 40 plus 0.1y. So if we did exports, which is 100, we would have 100 minus this expression here. And so our net exports then would be 60 minus 0.1y. So if we add all these together and simplify, we'll get that the aggregate expenditures function is 300 plus 0.5y. Notice again, this marginal propensity to expend got smaller. Again, that's because we have another leakage. So the marginal propensity to expend here is 0.5, okay? So before we had 0.6, and then now we're subtracting off the marginal propensity to imports. So anyways, the slope of this is 0.5. And so the marginal leakage rate is another term that the textbook uses, and that's just 1 minus the marginal propensity to expend. And so here 1 minus 0.5 is also 0.5. So how do we get the multiplier? Well, the multiplier is always 1 over 1 minus the marginal propensity to expend. And you could also rewrite 1 minus the marginal propensity to expend as the marginal leakage rate. And so the multiplier is 1 over the marginal leakage rate. Same thing, it's 1 over this. This can be written as marginal leakage rate. So when we calculate the multiplier, we get that it equals 2. So this is just an illustration of the circular flow again. So here we know that expenditures are injections into the circular flow, and that the marginal propensity to expend measures the percentage of expenditures that get injected back into the economy each round of the circular flow. So this is just showing you the different, you could think of the injections and leakages here. So our injections would increase the flow of this, but the leakages lower it. So the marginal leakage rate represents the percentage of income flow that is withdrawn from the economy for each round of the circular flow. So, I mean, we can see here that investment is an injection. Savings is a leakage, right? And we have taxes is a leakage, but government spending is an injection. And so this savings here would be leaving, but investment would be injecting back into it. So anyways, so there's a very strong correlation, I guess. The ideas of what we talked about here are similar to what we talked about when we talked about the circular flow. Okay, so we're going to finish up with deriving the aggregate demand curve given our Keynesian cross model. If you remember in the last lecture, I mentioned that every point on the aggregate demand curve is an equilibrium point. Well, this is what I meant. So let's start with Keynesian cross diagram in the top here. And we are drawing an aggregate expenditures function for a given price level, okay? And so this equilibrium, the equilibrium for this aggregate expenditures line is right here, okay? So what we're gonna do is we're gonna change prices and trace out our aggregate demand curve, okay? So if prices are P0 and our aggregate expenditures function is given by this, then we are going to have real GDP equaling Y0, okay? So remember, the aggregate demand curve is in the price level and real GDP space. So we're just going to plot this information down here. So when the price level is P0, that real GDP is Y0. Okay, so that's 1 point on our aggregate demand curve. Suppose the price level to be P1 instead of P0. So we know that this, P1 is higher than P0. So these are higher prices. And we know that higher prices, all else constant, would result in less expenditures because people, the purchasing power has fallen. So this new equilibrium point here is plotted below. And so we have Y0 or Y1 here, and then we plot the price level, P1. And again, P1 is greater than P0. So that's another point on our aggregate demand curve. We can do that again for another price, plot the point, and this then is our aggregate demand curve. Now, suppose that we have these different prices here. Now, suppose, for example, that we increase investment expenditure or something like that. We know then that the aggregate expenditures function for all of these would shift up by that amount, okay? And that then, if we were to replot everything, we would end up plotting points to the right, and the aggregate demand curve would shift to the right. So if something like investment expenditures increases and prices are held constant, that corresponds to a shift in the aggregate demand curve to the right. Okay, so that's just some insights on where the aggregate demand curve can come from. When we look at the aggregate demand curve, we have varying price levels and the real GDP in the economy. When we look at the Keynesian cross model, we're typically holding prices constant and then, changing autonomous spending and then having this shift. So then we would, if we think of it shifting for something like investment, we would have all P0s here, but it would be shifting down if, for example, investment spending were falling. Okay, but we know that if we hold the other things that determine aggregate expenditures constant and just change the price level, we're talking about different points on the aggregate demand. Okay, so if we have, again, let's think about what we're saying in terms of this Keynesian cross model in our price level and real output space. So we're basically saying in the Keynesian cross model that prices are fixed, okay? So that's our aggregate supply. So if aggregate demand if we had an increase in autonomous expenditures, like an increase in investment, and here the example is an increase of 20. So if we have this happen, so that's the initial increase in spending, and we know through the multiplier effect, we'll get a much larger increase. And so the aggregate demand curve would be shifted to the right all the way here. So if we have an increase in autonomous spending and prices are fixed, then as a result, the multiplier effect would bring us all the way here. So we would have that real output increases by this amount here in total as a result of this initial shift. Okay, but we know that if prices aren't fixed, we're going to have an upward sloping aggregate supply curve. And so the new equilibrium will actually be at a point less than this. But if we're holding prices constant, the full shift in the aggregate demand curve is the initial shift plus the induced shift from the multiplier effect. So anyways, if we look at any shift in aggregate demand, the horizontal difference here will include the initial increase in the injection plus the added multiplier effect. Okay, so we'll just finish up with an algebraic example. So let's suppose the economy is described as follows. So we have aggregate expenditures is equal to C plus I plus G. So we don't have a foreign sector here, so we can think of the economy as being closed. This is our consumption function. This is investment. This is government spending. And we're going to keep things simple and just have a lump sum tax of 100. So how do I derive the equilibrium level of income for the economy? So does anyone want to type in the chat function how I would go about doing that? So the first thing we want to do is remember that the first thing you always want to do with these questions is write out your aggregate expenditures function. So here at C plus I plus G, there's no foreign sector. And then we substitute in what we know. So we know that the consumption function is 60 plus 0.6 times disposable income. We put that there, add in our investment, and we add in our government spending. So we have 250 plus 150. Okay, now we know taxes are 100. We're going to plug that in. And so we have 60 plus 0.6 y minus 100 plus 250 plus 150. Now we just need to simplify this, and we get that the aggregate expenditures function is equal to 400 plus 0.6y. And so how do we find the equilibrium level of income? Well, we impose the condition that in equilibrium, y is equal to aggregate expenditures. Okay, so we're just going to replace this AE with a y. Now we just need to isolate y. Do that, and we get y is equal to 1,000. Okay, so this would be the equilibrium level of income. On a diagram, it would look like this. We have our aggregate expenditures function, which is this here, and we look for where the 45-degree line hits it. That will tell us the equilibrium, and it's 1,000, and that's exactly what we solve. So it's good to practice a few of these questions. And so that's the end of the lecture. I'll just take a couple minute, maybe 2-minute break, and then what we're going to do is do one of our in-class exercises. Okay, just give me 1 minute and we'll return, okay? Okay, I'm back. Okay, so in this question, we're given a table here. It's of the full model. And first we're asked to complete the table above and then graph a 45-degree line and the aggregate expenditures function in grid on the right. Okay. And then identify the equilibrium. So how do we go about filling out this table? Well, let's take a look. So we know that here we have all of our income levels, and then we can see here that if the income level is 200, then taxes are 75. And if we increase income by 100, taxes go up by 25. When we increase income here by 100, we also get 25. So we know this is a linear function. So basically what we can do is just subtract 25 from here. We'll get 50, and then we'll get 25. Okay, so we can fill in the column doing that. And then disposable income then is just going to be y minus t. So once we have this filled in, we'll be able to get our disposable income. And then consumption, well, if we look here, we can see that for a change in income of 100, the change in consumption is 60. So then this always changes by 60. We're just assuming always linear functions here. So then we could subtract 60 from here, we'll get 60, and then subtract another 60, we'll get 0. And then once we have this column, savings is just disposable income minus consumption. Now, how do we get this column? Can anyone type that into the constant? And then the same with government spending. And the same with imports. So we'll just copy the 60 down, 150 down, and the 50 down. Now, imports. So if income changes by 100, how much does imports change? By 10. So our marginal propensity to import is 10%. So this is always going to be, the induced part is going to be 10% of income. But we can see that, for example, at 400, if we multiply 400 by 0.10, we get 40, but we have 50 here. So then the autonomous part, or the intercept, must be equal to 10. We can also just subtract 10 and keep going. So 40 minus 10 is 30, 30 minus 10 is 20, and so this must be equal to 10. Our net exports is obtained just from subtracting x minus imports, okay? And then once we have everything, we can just figure out what our aggregate expenditures are. We just add C plus I plus G plus XN. Okay, so I've actually put the table here filled out. So this is our table filled out, okay? And now what we need to do is plot a 45-degree line, and we're going to plot the aggregate expenditures function. So 45-degree line will just be line that goes through all the points that are the same. So, we want line to be right here. So that's our 45-degree line. It goes through all the points where what's on the y-axis is equal to the x-axis. So straighten it out a little bit. Okay. Now we need to draw our aggregate expenditures function. So what is our aggregate expenditures function? Let's actually just write it out here. So aggregate expenditures is equal to, what's the intercept of the aggregate expenditures function? Can anyone tell me what that is? 250, good. What's the slope of the aggregate expenditures function? So what's the change in aggregate expenditures with respect to a change in income? Yes, it's 0.5. So every time income changes by 100, expenditures changes by 50. So 0.5y, okay? So we just need to plot that. So we're going to start at 250. So this is 200. So 250 is around right here. And then we need to have a slope of 0.5. Okay, so if another, well, an easier way to plot this is to just, plot the information here. And then we don't need to figure out the actual numbers. So we know, I'll just actually plot a couple points first. So we know when income is 400, what is aggregate expenditures? Well, it's 450. So that's somewhere around there. I'm just going to make this a bit smaller, somewhere around there. Now, if income is, whoever made this grid here kind of, well, there's a lot of large numbers here. Anyways, if we, let's say we choose an income level of, for one that, so if we choose 700, so an income of 700, which would be, so this is going to be 1,000, so we're a little bit over here. And if it's 700, then the aggregate expenditures is 600. So that would be at this point here. If it's 700, going to be 600. So let me just, 400, 450. Let's do 800. So at 800, income, aggregate expenditures is 650. Would be something like here. So we can see it's going through and it's going to be, the equilibrium is going to be in here. Let's look and see what the equilibrium is. Well, we know the equilibrium is 500. That's where aggregate expenditures equals 500. So we'll put a point there. So this is 600. So 500 is here. And then we have, it's about here. Okay, so our aggregate expenditures function, we know it's going to be at, so this is 200, so it's going to be roughly here, and it's going to go through this here. Okay, so roughly, it's not perfect, but that's where it will be. Okay, so that will be our aggregate expenditures function, and we know that the equilibrium is 500. Okay, and so if we want to put the letter E there, note that. So that's our equilibrium right there. Even make that point a bit bigger. Well, it's not letting me do it. So that's our expenditure. Now we know, so if B, the answer is 500. Now, what are the total injections and total leakages? Does anyone want to add that up for me? So 260. So if we take our savings, our taxes, which is a leakage, our savings, and our imports, and add them together, we will get 260. 60 plus 50 plus 150, we'll get 260. What are our total leakages? Well, since we're in equilibrium, we know they'll be the same at 260. So the answer here would be 260 and 260, okay? And this here is 500, okay? What's the value of the marginal propensity to consume in this country? Yep, perfect, 0.5. That's the slope of the aggregate expenditures function. Now, what's the value of the multiplier? Yep, exactly. So 1 divided by 1 minus the marginal propensity to expend is equal to 1 divided by 1 minus 0.5. And so it's equal to 1 divided by 0.5, which is equal to 2. Now it says, suppose that exports from Armenia were to increase by 150. So we have a new injection. Draw the new aggregate expenditures function and label it AE2. So now we know that the aggregate expenditures function is going to shift up by 150. Okay, so 150. So unfortunately, this graph doesn't have the best numbers chosen, but this is going to shift upwards 150. So we know that each box here is 200. So it's like 0.75 of a box. So basically we know then that now the intercept will be 400. So we'll be right here, okay? Shift up parallel. And then it asks us to identify the new equilibrium. So we could look at this column here and then just add 150 to it, okay? And then we can see where the equilibrium would be. So if we add 150 to aggregate expenditures at the income level of 800, we're going to get 800. So then we'd have 800 here, 800 here. We know that's the equilibrium. Okay, if we add 150 here, we're not going to get any, if we add 150 to all of these, we'll see that the only one equal to income would be the last one here at 800. And that corresponds to this point here. So the new equilibrium will be at that point there. We'll be moving up to this point here. So that will be the new equilibrium point at 800. Okay, now at this point, what is the value of the new expenditure income? Well, we know it's 800. And at equilibrium, what is the value of net exports? So what's the value of net exports here? It would be 110. So net exports net exports at 800 is equal to our exports, which is 50, minus our imports are 90. So it actually would be equal to we had an increase in exports of 150. My mistake. So we know that at this point here, exports now are going to be 200, right? So 200, because we're adding 150. That's what we were asked to do in part F. So it'll be 200 minus imports, which are 90. And so we end up with 110. Okay. All right. So that concludes the lecture for today. I'll open it up to see if anyone has any questions. Questions? You can use the mic if you want. So how do you get the y 0.4y? Where was that? Is that in a previous slide? Oh yeah. So you're talking about this slide. So here in this question, we start out with our aggregate expenditures function, and then we're going to plug everything in. So we know the consumption function is this here. So we're putting that there. And we're adding our investment and government spending, which is given. Now we're going to just work this out. And we're going to realize that taxes are equal to 100. So we're going to plug that in. So we're just going to simplify this. So when we do that, we get that aggregate expenditures is equal to 460. So it's actually equal to 400, right? Because if we add 60 plus 250 plus 150, and then we subtract the 60, which is 0.6 times 100, we will end up with 400, okay? And the only thing left in front of y is 0.6, so that's 0.6. And so now to solve for the equilibrium, we set aggregate expenditures equal to y. I mean, this is basically just solving two equations, two unknowns, right? We have two equations, the aggregate expenditures function, then we have this other equation, which is just that AE equals y, okay? And so we're just substituting in, solve by substitution. So we know that y equals AE, so we're just going to put y here instead of AE, solve for y, and we get that so if we put the y in here, we're going to bring this 0.6y over to the left. And so we'll have y minus 0.6, right? And so we have 1y and we owe 0.6y, because when we bring this over, it'll be negative. And so 1 minus 0.6 is 0.4. So we have 0.4 y's. That equals 100. We just divide both sides by 0.4, and we'll get y equals 1,000. Okay? Does that make sense? So I'll try to get the video posted if you want to watch it again. And let's just take a peek at our weekly schedule. Can everyone see the weekly schedule? So we've covered Chapter 6, Aggregate Expenditures. Okay, and our next class, which is next Wednesday, right? June 3rd. We're going to discuss fiscal policy, and then next Friday we will have the midterm exam. Okay, the midterm exam will be online, and I already talked a little bit about it before. I'll send out a more precise email, but there's not too much else to say. There's going to be multiple choice questions from Chapter 3 to 7. I haven't decided. I probably won't be able to add a short answer question, so I think I'm going to stick with multiple choice. But it's going to be a balance of definition, sort of knowledge-based questions, and a good amount of application questions where you have a chart or something like that, okay? Or a table, and you need to calculate numbers or shift a curve or something like that. Okay, so it'll be at least half application or more, and then the other bit, some definition questions. Okay, so unless you have any other questions, we'll call it a day. Great. Well, I hope everyone has a great weekend, and we'll see you on Wednesday. Another question, is the midterm open book? Well, it's not supposed to be. However, obviously, that's not going to be easy for me to enforce. All I can say is you're not going to have time to learn the material during that 2-hour time slot. So if you don't study or know the material, then it's not going to help you all that much. So it's not, I mean, I can't stop you from having your textbook while you're doing it. So, I guess I can say that it is open book, but that doesn't mean you don't need to study. You're only going to have, the 2 hours to complete the questions. So, might be a bit tight. So you don't want to be just relying on that. Okay. There's going to be 40 or 50 multiple choice questions. I'll let you know. I'm pretty sure it's 40 multiple choice questions. Okay. And then you have 2 hours. So, you have a couple minutes maybe for each one. So yeah, you don't have time to learn the material. Okay. So that's my advice. So make sure and just because the exam is multiple choice, that doesn't mean you shouldn't be doing the non-multiple choice questions. The question type is irrelevant because you can assess any concept with any question type, right? So I could ask you to solve something, put the answers in a multiple choice question, and you have to pick the right one. So you should learn how to solve that, right? So my suggestion is to make sure that you do as many questions as possible. So I've posted the solutions to the end of chapter questions, so you should be doing those. You should be looking at the exam practice problems I have posted on Slate, so you have some other examples there. And you also have some self-check quizzes in the Connect package, right? So you want to go in there and practice those as well. So if you master the concepts, you should do fine. I'm not putting any trick questions on the exam. It's a very fair exam. It's well balanced across the learning outcomes. So if you study and learn the material well, you should do well. If you wait to the last minute, maybe not so much. Okay. Okay, great. Well, again, have a good weekend, and we'll see you next week.